A confirmation about the audio, please. If the audio is clear and available, kindly confirm. Thank you. So now we talk about the ozone layer. And here we talk about the stratospheric ozone. Now, when we talk about the ozone layer, that ozone is basically present in the region of stratosphere. So if we talk about the layers of atmosphere, this is the troposphere. This is the region of stratosphere. Now, within the region of stratosphere, we have a distinct presence of ozone molecules. And that is what is referred to as the ozone layer, or what is also regarded as ozonosphere. Okay. Now here, this is considered to be very vital for the life systems on the planet, because this ozonosphere, it consists of oxygen in the presence of O3 molecules. Now these O3 molecules, first of all, how is it that this ozone is produced? Why is it that you have the presence of that particular kind of arrangement of oxygen atoms at this particular region? That is because at this greater height, these oxygen molecules or oxygen atoms in the presence of ultraviolet rays, they end up reacting and interacting and produce O3 molecules rather than O2. And their prime purpose is to filter out the ultraviolet rays of the sun. Now, the solar rays, they are received in various different spectrums and various different types of wavelengths, and ultraviolet rays being one of them. So these ultraviolet rays, they are then reflected back. Okay, so that is your ultraviolet rays. Okay, now here, that is where this ozone layer comes into play. That is where it comes to the aid of all the biosphere in general, because that ultraviolet rays is not something which is conducive or productive for the life on Earth. It is something which is detrimental for life on Earth. So by shielding us from these ultraviolet rays, that ozone layer forms a kind of a protective shield. Now, how is it that we measure the density or the thickness of ozone layer? It is basically done with the help of the measuring the concentration of ozone, and that is by a unit that we refer to as Dobson unit. Dobson unit. That Dobson unit is used to indicate the concentration of ozone. Now, you would have heard about the term depletion of the ozone layer, and you would have heard about the terminology such as ozone hole. So when we say an ozone hole, what do we mean by that? So whenever you talk about the ozone hole, so let's suppose it is not a complete gap which is created, but rather in certain areas, if you consider this to be the ozone layer, in certain areas the concentration of the ozone molecule goes particularly low. Okay, so once the concentration happens to be very low, they don't have the ability to filter out the ultraviolet rays, and the ultraviolet rays, they basically are able to push through. So that is where we have the impact created, and there is a significant amount of disadvantage created due to the exposure to the ultraviolet rays. Now, this region where the concentration of ozone molecule reduces so significantly so that it is unable to filter out the ultraviolet rays of the sun, that is what is regarded as the ozone hole. So the region where the concentration of ozone molecules are particularly low, okay, so that they are unable to filter out the UV rays of the sun, that is regarded as ozone hole. Okay, now that is the aspect of the ozone layer. Now here, or the ozone hole which is created. Now why is it, or when is it that the concentration of ozone molecules that reduces significantly? So that is created by certain substances which are categorized as ODS, or ozone depleting substances. So that is when these substances, they interact with the ozone molecules and they end up reducing their concentration. So this is created by the interaction of ozone molecules or ozone depleting substances such as chlorofluorocarbons, hydrochlorofluorocarbons, etc. with ozone molecule. Okay, now much of the ozone is concentrated in a portion of the stratosphere that we refer to as the ozone layer. It is roughly at a height of around 17 to 26 kilometers above the ground surface or the sea level. Now, most stratospheric ozone is produced when some of the oxygen molecules in this layer, that is in the region of stratosphere, they interact with the ultraviolet rays. Because please understand, the oxygen that is present near the ground surface, that is present in a stable state, that is O2. This is something which is breathable, that is something which is consumable by the various individuals and the species living on the planet. But when it comes to O3, that is produced when you have the oxygen ions and atoms interacting in the presence of ultraviolet rays. So this production of ozone, this production process is very slow. Production process is very slow. Okay, that process of production of ozone is very, very slow. Whereas that process of reaction with the ozone molecules is something which is very hastened, which is very fast. Okay, so here you come across a situation where the process of consumption of ozone is very fast. So that is why overall, as these ozone depleting substances, they continue to have a kind of a free reign and a kind of a free flow, they will end up creating these large deficiencies in the ozone. That is what we refer to as ozone hole. Now, this is primarily created by the various different halons or halon group of molecules, hydrofluorocarbons, chlorofluorocarbons in themselves, hydrobromofluorocarbons, all of them, they end up creating that kind of an impact. Now, where are these used? All these CFCs, HCFCs, traditionally and historically, they have been used in large quantities for air conditioning, right? For any coolant purposes. In order to provide the cooling activities, that is where they have traditionally been significantly utilized and used. So here, basically, you have to understand that all of these materials, that is the CFCs, etc., slowly and steadily they stay in the atmosphere for a very long period of time. They enter into the stretches of stratosphere, and particularly around the region of the poles, aided by a lower temperature, that is when they become chemically active, and that is when they start reacting with the ozone molecules. So the CFCs, right, they move into the stratosphere over a longer period of time, then aided by movement of air, they reach the colder regions, then the substances become chemically active at very low temperatures and interact with ozone molecule. Now, this reaction is very simple. As per the reaction, the ozone molecule is broken into O2 and an oxygen atom. Now, oxygen, that is O2, doesn't have the same kind of scope when it comes to the fact of fighting with or filtering out the ultraviolet rays. They don't have the same capacity. So that is why they allow the ultraviolet rays to reach the surface and cause a significant amount of damage. So if you take a look at the reaction which is unfolded, basically at a greater height, and when we talk about the lower temperature, that lower temperature is something which is attained at the region of the poles, but it is not only restricted to the polar area. That is something which is also observed in the other regions of the planet. So if a question comes that ozone hole is only restricted to the polar areas, here the word only is a catch. So ozone depletion is observed across the planet itself. But a large scale ozone hole, they are created over the region of the poles because of extremely low temperatures which are experienced over the region of the poles, and that is when, in the presence of the very low temperature, that is when these substances they become chemically reactive. So here, once they reach at a higher elevation, now these ozone depleting substances such as CFCs, they also get impacted by the ultraviolet rays of the sun. And once they get impacted, so the chlorine atom in them, that starts to separate, right? For example, let's suppose you have CFCl3. So in the presence of ultraviolet rays, when the ultraviolet rays they come in, so that will have a separation of chlorine atom. Now this chlorine atom will straight away attack the ozone molecule, and once it interacts with the ozone molecule, it produces chlorine monoxide plus O2. Okay, now this chlorine monoxide will interact with a free oxygen radical. It will end up creating chlorine ion again plus O2. Now this chlorine atom, it is free to react again, and then again this process is repeated. So by the time that an ozone molecule is manufactured with the help of the ultraviolet rays, in that time duration, there has been a significant number of reactions of depletion which have already taken place, leading to an overall depletion. So the net effect is that ozone gets converted into oxygen. So overall, this is the depiction of the reaction, and here you will observe that in the presence of the solar and ultraviolet rays, the chlorofluorocarbon that gets separated into chlorine atom, individual chlorine atom, and CFCl2. Now that individual chlorine atom interacts with the ozone molecule to produce chlorine monoxide, and also it produces oxygen molecule. And in the meanwhile, the chlorine monoxide, that is again something which interacts with oxygen to produce a free chlorine atom. This then is available for further reactions to happen and cause further depletions as well of ozone layer. So the reaction to break the ozone is much faster as compared to the reaction of formation, and this is able to carve out, creates ozone hole. How do we measure it? With the help of Dobson unit. So this reaction is something that you need to highlight if you are writing a mains answer, and UPSC has asked a kind of a mains question from this a lot of times earlier as well. So whenever you are confronted with a mains type of question here, always end up indicating that kind of a reaction, and that is something which will add heft to your answer. Is there a geopolitical relationship between relatively successful Montreal Protocol compared to climate change agreements, as the depletion of ozone layer occurs mainly in higher latitudes, where mostly developed countries are compared to developing and LDCs in tropical regions? So one of the reasons for the success of Montreal Protocol is its framing and its adaptability to the changing conditions, and also a global realization that the ozone layer is indeed basically depleting. Okay, now it is a different matter altogether that when we talk about the ozone layer, here the significant portion of these pollutants, that is the CFCs, they have historically been emitted by the developed nations of the world, and the developing nations, they did not even get a chance to emit that much amount of CFCs at all. right? So that is why, because the owners squarely lied on the portion of the developed nations, and they could not shift the blame at that point of time that no, India is also emitting CFC, because the world also knows that in the 70s, during the 60s and the 70s, when that ozone hole started getting created, countries such as India and China, they were basically struggling to provide basic necessities such as provision of electricity. So let alone the provision of air conditioning, let alone the provision of refrigeration and coolants. So India and China could not be held, and such developing nations could not be held to be responsible for the depletion. And that is why they had no escape or the wiggle room. In the case of climate change conventions and protocols, the developed nations, they have a kind of a slingshot, they have a kind of an excuse where they can always say that, look, we did that earlier, but right now in countries like India and China, they are polluting, so they should be held accountable, they should be made responsible. That is the reason why they are able to escape the blame so very easily. Okay, and that is why they are shying away from taking any responsibility. But in the case of ozone layer, they could not do so. And the Montreal Protocol, that was basically arrived at much earlier. And by that point of time, industry had started bringing in alternatives already, because the level of awareness which was created was very, very significant. Okay, so Binika, I hope that solves your query. Yes, depletion of ozone layer can be asked in the presence. The type of question that I told you about the regions where you have the ozone hole, the presence of low temperature conditions, all these can always be asked. Okay. Now, then when we talk about the causes of depletion, the causes of depletion can be the ozone depleting substances, or ODS, as we have talked about. So these are basically your ozone depleting substances. Depleting substances. Is that understood, Benita, or is there any further doubt which prevails? Please do not hesitate to ask questions, particularly in this condition. Okay, any doubt that prevails, please ask them. So ozone depleting substances, you have a whole list of them. For example, here, these are your all the ozone depleting substances. Majorly, you will observe all of them to be used in refrigerators, air conditioners, solvents, dry cleaning agents, fire extinguishers. That is adhesives. So that is where all these ozone depleting substances, they were basically used. Okay, so that is where these are used in refrigeration, were used in as refrigerants, fire extinguishers, etc. But CBDR is there in UNFCCC also. But then if you observe the aspect of CBDR, now in the last conference of parties, Australia basically attacked the basic concept of CBDR. Australia made a statement on behalf of the developed nations that, look, we emitted those gases when you did not have modern technology. Now modern technology is available, so you cannot basically emit anymore. So that is where they are escaping from that CBDR. Had they been following CBDR to the book, there would have been no issue in the case of UNFCCC. What happened when Trump was elected as the president of the United States? Immediately that entire concept of CBDR had been challenged. Even though when you talk about the presidents, the Democrat presidents in the United States, such as Joe Biden, for example, Barack Obama, all of them, they are so-called champions of climate change, isn't it? But then when it comes to the action on the part of American industry, they always take a backseat. It is the industry which basically dominates the entire conversation. And that is why they are never able to adhere to that CBDR. These are the same countries, the developed nations, who have not even achieved the goals that they declared as per the Paris Agreement. In the case of United States, it pulled out of Paris Agreement. United States did not even adhere to the aspect of the Kyoto Protocol. But when it comes to countries such as India, they are always there to provide a kind of a free gyan, a kind of a free knowledge and wisdom. So that is where the CBDR is only there on paper, and there is no real outcome of that. That is the crux of the problem in the case of the climate change convention. There is a consistent changing of the goalpost. Earlier it was the fact that fulfill the requirement of the Paris Agreement, your work is done. But now the goalpost has been changed to, okay, switch over to net zero emission, then your work will be done. Now once there is a pressure on the side of the electric vehicle industry, then they are saying, okay, adopt electric vehicles, and then your work will be done. Always in these countries you will find there is a great amount of tussle, there is a great amount of push and pull, and that ends up creating that kind of a limbo which exists and which creates a lot of log jams and failures in terms of achieving any realistic goal. Now, that ozone is also depleted as a result of the natural factors. So that ozone layer, which natural factors or natural agents can lead to the depletion of ozone layer? Do we have any clue? So climate change affects tropical countries more severely compared to temperate countries? Not necessarily so. Not necessarily so. Climate change will impact them as well. It is ignorance on their part. So when we talk about climate change, we will understand that how even the temperate regions, they will be impacted quite significantly. So when we talk about the causes of depletion of the ozone, you have the natural factors. What are these natural factors? One of the factors is, for example, forest fires. You also have, very good, volcanic eruptions. In these cases, oftentimes the plume or the smoke and also the disturbances, they are emitted for many kilometers from the surface. And due to the impact, they end up puncturing the region of the ozone layer. They end up creating a kind of a gap in the region of the ozone layer, and that creates a large ozone hole in the process. Just a moment, guys. Okay, so that is how they end up creating that particular ozone hole. Now the impact due to ozone hole is primarily because of the exposure which is caused to the ultraviolet rays. So the exposure to ultraviolet rays, that impacts us human life as well. How? Because when we are exposed to those ultraviolet rays, it causes skin lesions, skin infections, and also ends up causing significant amount of diseases such as skin cancer as well. So here, this impacts, this is created by, this ends up creating a condition of skin lesions, infections, and even cancer. What about the animal life? Now, animal life in various waters, they are impacted because of exposure to UV rays. So, for example, in many of the animal species, it has been recorded that when they are exposed to ultraviolet rays, their overall productivity and also their reproductive cycles, they are impacted. Okay, so here, reproductive cycles are impacted, significantly impacted. Okay, then what about marine life? Again, in the marine life, due to overexposure to ultraviolet rays, you have the coral reefs. They also undergo bleaching activity. Their ability to synthesize calcium carbonate and form that calcium carbonate exoskeleton, that is damaged. Their mutualistic relationship with zooxanthellae, that is damaged, because when they are exposed to UV rays, they start expelling out significant amount of zooxanthellae. So that leads to coral bleaching. So this leads to significant coral or bleaching of the coral population. Okay, and that ends up impacting the marine life, marine ecosystem. Then other than that, exposure to significant amount of ultraviolet rays. Ultraviolet rays have a greater amount of energy. So the exposure and the prolonged exposure to ultraviolet rays, that will also bring about a sudden rise in temperature, and a prolonged rise in sea surface temperature also happens. So because of exposure, due to exposure, you have a detrimental impact or increase in sea surface temperature also over the long term. Then after that, there is an impact on the plant life as well. What is the impact created on plant life? So the plants, they produce food and they are able to produce biomass, which will be consumed by the rest of the community and the rest of the species by the process of photosynthesis. And photosynthesis forms the bedrock and the bulwark for the entire genesis and the survivability of the ecosystem. Now, when you have an overexposure to UV rays, the leaves, they start wilting. Their productivity reduces, the rate of photosynthesis reduces, their metabolism slows down, and the amount of productivity that is carried out by the plants in general, that will reduce. So in a way, you can think about it that the entire energy pyramid that we studied, that energy pyramid in itself gets dismantled. Sea surface temperature rises, reduces survival of plants. Yes, correct. Sorry very much. So here, when we talk about the plant life, plant productivity reduces. And when the plant productivity overall reduces, this impacts the availability of nutrients for the ecosystem in general. So that is basically the impact of the ozone hole. And this impact is purely due to overexposure, or simple exposure itself would also do exposure to UV rays. Okay. Now, after that, we come to the aspect of conservation or the protection of the ozone layer. Now, that is done, and that has been done quite successfully for that matter, with the help of the various different international agreements which have come into the picture. Now, it all started around the early 1980s, and by the 70s itself, the scientists had started recording the increased amount of ultraviolet rays exposure in various different regions. It was always found out and always observed that the ozone hole created over the region of Antarctica was much larger as compared to the ozone hole created over Arctic. And there's a geographical reason behind that as well. Why is it that the ozone hole created over Antarctica is much more uniform and larger as compared to the one over Arctic? Because over the Arctic, historically, if you will observe, the shape, the size of the ozone hole, it keeps on varying continuously. And the reason and the answer is quite simple. Antarctica, can anybody of us take a guess about that? Can we have a guess that why is it that over Antarctica the ozone hole is much more prominent? Take a guess, even if it is incorrect, doesn't matter. Very good, Himanshu. Antarctic region has the permanent cold weather as compared to the Arctic. Cold atmosphere helps in reaction due to low temperature, uniform temperature throughout. Very good, Vinita. Low temperature, more water and ice in southern hemisphere. So let us understand that. When we talk about the atmospheric stability and the atmospheric composition over the region of Antarctica, that is much more uniform. Because Antarctica is a large landmass, a consistent landmass covered with a lot of ice. So the air circulation and the air mass over the region of Antarctica is much more stable. So once you have a stability of conditions, the reactions are basically much more prolonged and much more uniform. Whereas over the region of the Arctic, due to frequent melting and freezing which happens, the temperature conditions keep on changing. The air movement, the weather pattern keeps on changing quite drastically. So that is why even the reaction between the ozone depleting substances and the ozone molecule, that is something which is transitionary in nature. It is not permanent in nature. So that is why ozone hole created over Antarctica is much more permanent in nature, much more prominent in nature as compared to the one created over the region of the Arctic. Let me write it down somewhere. So here, ozone hole, because I want you to take a note of that, because if you have studied geography, if you have studied environment in this much detail, there is no reason why you should not know about these particular factors. And these are asked by the exam. That is the prime purpose here. So here, ozone hole created over Antarctica is much prominent and consistent as compared to the ozone hole over Arctic. And that is because of consistency in terms of the airflow movement, which is attained over Antarctica. I hope that you are able to understand this and you will be able to justify this further, that why there is a consistency of airflow, because Antarctica is a kind of a large continental landmass covered with ice, and that is a consistent phenomena, whereas when we talk about the region of the Arctic, it is transitionary in nature, with the freezing and the melting of the ice subsequently changing the face of the Arctic every season, and that is when it is something which is transitionary in nature as well. So here, the initial discussions and the conversations which happened was in the form of Vienna Convention. Now, before we start with the Vienna Convention, the Montreal Protocol, it is only apt that I tell you the basic difference between a convention and a protocol. So when we talk about a convention, I'll give you at a later stage of time, I'll give you the theory, the definitions of that as well. When we talk about a convention, convention is an expression of will that, okay, we will do this in order to achieve the objective. We will be doing this. That is a convention. So for example, again, let's suppose many of you, and this is the most apt example for all of us here who are preparing for the civil services. Let us say 4 or 5 of us, we get together, we decide to have a kind of a preparation for civil services. And all of them decide that we will prepare for civil services, we will clear this examination. When, why, where, how, nothing is decided, but we'll clear the exam. That will be your convention because you are trying to achieve an objective. But after a few days, then you again meet to decide that, okay, we will clear this exam in 2024. And for clearing the exam in 2024, we need to be completing the optional by December. We need to be taking the test series from the month of November. The final phase of revision needs to be started by March. Then the second phase of revision needs to be started by April. Expression of will that, okay, we will do this in order to achieve the objective. We will be doing this. That is a convention. So for example, again, let's suppose many of you, and this is the most apt example for all of us here who are preparing for the civil services. Let us say 4 or 5 of us, we get together, we decide to have a kind of a preparation for civil services. And all of them decide that we will prepare for civil services, we will clear this examination. When, why, where, how, nothing is decided, but we'll clear the exam. That will be your convention because you are trying to achieve an objective. But after a few days, then you again meet to decide that, okay, we will clear this exam in 2024. And for clearing the exam in 2024, we need to be completing the optional by December. We need to be taking the test series from the month of November. The final phase of revision needs to be started by March. Then the second phase of revision needs to be started by April. That is your timely depiction of the targets. That is your protocol. So protocol talks about and includes the presentation or the inclusion of the portion of the timely completion of the targets, whereas the convention is very vague in that matter. Convention is much more open-ended in that respect. So here, first of all, in the mid-1980s, you had the Vienna Convention around 1985, which was held. It formalized the international cooperation on ozone issue by creating framework for protection of ozone layer. The intricacies, the final details, etc., they were still not finalized up till this stage. Now, it entered into force at a much later stage, but then this paved the way for the Montreal Protocol. Paved the way for Montreal Protocol. Okay, now when we talk about Montreal Protocol, this was one of the first global protocols to talk about the any kind of conservation for that matter. It is one of the earliest ones and the most successful ones. So this Montreal Protocol is on ODS, ozone depleting substances. Now, as I told you, throughout the 60s, the 70s, and early 80s, there had been a lot of research which was carried out about understanding the atmosphere. And it was at that point of time when the world came to know that the air conditioning units, the refrigeration units that we are using, they are primarily responsible for the depletion of the ozone layer. And once the ozone layer gets depleted, there is no coming back from that particular stage, and that will be the end of it. So that is where people started working upon it, and you had a large-scale awareness which was reached. CFC till that point of time would be used in almost all the various refrigerants, in all the various coolants, in all the various different types of air conditioning units, cold storage units, everywhere. Now, already by the time that this Montreal Protocol, that meeting happened when in 1987. So by the time that the meeting for the Montreal Protocol happened, already the industry had developed a kind of an alternative. And the industry said that, look, you are saying that CFCs are damaging. Fair enough. I will use HCFCs. So for a few years, the world used HCFCs. Till the scientists, when they carried out the research, they found out that even these HCFCs, they are equally damaging to the ozone layer. Then this was also banned. So one of the beauties of this Montreal Protocol, or one of the very tactful aspect of Montreal Protocol, is how it has basically changed itself with time. It has adapted itself with time. Now that is one of the reasons for its runaway success. So it talked about the phasing out of production and consumption of man-made ozone depleting substances in a kind of a phased manner. Now for that, various different countries, particularly the tropical nations, they required to have a kind of an alternative setup established as well, right? And that is when a multilateral fund was also established way back in 1991. Why? To implement that aspect of the protocol that you have to phase it out. So you have to develop the alternate mechanism, and you have to develop alternate technologies as well. So for that, you will require some money. So for that, this multilateral fund was established. Okay. So here, basically to provide financial and technical assistance to developing nations and parties to the Montreal Protocol whose per capita emission was significantly less than 0.3 kg. Now, this fund is implemented. This is important for your prelims. This is basically implemented by United Nations Environment Program, United Nations Development Program, World Bank, and United Nations Industrial Development Organization, because it is the industrial sector which significantly was hampered and was impacted by this. Now, after this, there have been various different amendments which have been brought to the Montreal Protocol. The first amendment, or one of the major amendments which was brought in, was the London Amendment of 1990. Now, you are not supposed to learn the details of this amendment, but if a question comes about Montreal Protocol, if you are able to recount some of the very important specifics about this amendment, that would add much greater weightage to your answer. That would make your answer much more valuable. Okay, so keep that in mind. So it changed the ODS emission schedule by requiring the complete phase out of CFCs, halons, and carbon tetrachloride by 2000 in developed countries and by 2010 in the developing nations. Okay, this was a target which was set. And then methyl chloroform, which was also identified as an ODS, was also added to the list of the controlled ODS, with a phase out in developed nations targeted in 2005 and 2015 for the developing nations. So as per the London Amendment, what was done? Phase out target was decided that ODS would be phased out in developed nations by 2000 and in developing nations by 2010. And then even methyl chloroform, where was methyl chloroform used? If you take a look at it, in various different aerosols, adhesives, etc. That is where methyl chloroform was used. So basically, the phase out of methyl chloroform by 2005 in developed nations and 2015 in the developing nations. There were other amendments also which were brought into the process. For example, you had the Copenhagen Amendment. Now, Copenhagen Amendment, which happened in 1992, it accelerated the phase out of ODS and incorporated HCFCs. As I told you, when the phase out of CFCs was being planned and stretched upon, the industry came up with an alternative of HCFCs. Now, the Copenhagen Amendment is known for including HCFCs. So by London Amendment, we included methyl chloroform. By Copenhagen, we included HCFCs, right? Now, under this agreement, CFCs, halons, carbon tetrachloride, and methyl chloroform were targeted for complete phase out in 1996 in developed countries. Think about it. Here, earlier, what was the target? 2000 in developed nations. Here, what was the target? 1996. Now, this is a meeting which was conducted in 1992. So in 1992, you decide that you will phase it out within 4 years. How is it possible? It is simply impractical, isn't it? Now, whenever there is a meeting, a summit which is held in any particular country, that country has got a kind of a pressure to bring about media headlines that, look, I have brought this kind of change and now the world is a better place. So that is why oftentimes very impractical targets have been set historically. The world has learned from it. The world has learned that this is only for media glare. And that is why nowadays that kind of an aggressive target setting is no longer done. Obviously, it is something which was not achieved in 1996. And that is where these kinds of amendments, they don't hold any weight at all, other than the fact that HCFCs were included as per the Copenhagen Amendment. Then you had 10 years of Montreal Protocol being celebrated by another meeting at Montreal. And that was where the Montreal Amendment was brought in 1997. So this included the phase out of HCFCs in developed nations as well as developing nations. Then came the Beijing Amendment. Now, Beijing Amendment. This was important because by this point of time, a new pattern, a new trend started emerging. And what was this trend? While the various different developed countries of the world, including the region of North America, including the region of Europe, the Western Europe, the so-called climate preachers for us. Now, what they said that, look, we will never be using, or we are not going to use these ozone depleting substances. So in our domestic market, we are not going to use that. But then their industries, they continue to manufacture that. Why? To be supplied to the developing nations and the LDCs of the world, the least developed nations of the world. Why? So that nobody can put a blame on them. So it is just like, for example, in a kind of an analogy, think about it, that our neighbor, Western neighbor Pakistan today says, or has always been saying, that we will not be indulging in terrorist activities. But then there will be various different terrorist groups operating from that region and exporting that terrorism in the outside other part of the world. So similarly, the various industries, they continue to reap good dividends and very good income by still manufacturing these CFCs to be used in other nations of the world. So in a way, they were basically carrying out that kind of a proliferation of sorts, if you can refer it in that aspect. So that is why the Beijing Amendment included tightened controls on the production and the trade of the HCFCs. Bromochloromethane was added in the list with a phase out target. So here, production and trade was included. Okay. Now, eventually, obviously, this is something which has happened over a long period of time, and alternate to HCFCs were developed. Now, the alternate which was developed earlier, the CFCs alternate was developed as HCFC. Then the alternate to HCFC was also developed, and that was basically your what we refer to as hydrofluorocarbons. Hydrofluorocarbons, or what are regarded as HFCs. Now, these were thought to be an eco-friendly alternative to the ozone-depleting substances because it was understood that, look, CFCs are damaging the ozone, HCFCs are damaging the ozone, HBFCs are damaging the ozone, HFCs won't damage the ozone. But upon greater study, it was found out, and there was a detailed study which was published in 2015, which indicated that these HFCs, while they are not creating an ozone hole, they are forming the globe because they do not end up depleting the ozone layer, but they are very, very potent greenhouse gas. So, while they do not damage the ozone significantly, they do have a very strong impact on global warming. Okay, they have a very significant and a strong impact on global warming. So that is when you had the Kigali Amendment to the Montreal Protocol, which was arrived at in 2016. Kigali is the capital of, the map is also there, so there is no point asking this question. But nonetheless, let me see. Kigali is basically the capital of Rwanda. Kigali is also important because it is one of those areas which was very successful in eliminating the usage of single-use plastics. Rafia, HCFCs basically means hydrochlorofluorocarbons, which was included in the portion of ozone-depleting substances when, as per the Copenhagen. So if you take a look at the Copenhagen Amendment, that is where HCFCs were included. Okay. Now, here the Kigali Amendment was arrived at. Now, here this is having a goal of HFC, reduction of HFC consumption, hydrofluorocarbon consumption, right? So this will help reduce the production and consumption of HFC, which was a potent greenhouse gas, and thus avoid global warming of up to 0.4 degrees Celsius in this century itself. So you can understand and imagine the impact created. Now, again, this Kigali Amendment was a very nice amendment to be brought about because this brought about a phased target mechanism. Phased target mechanism. Now, that phase targeting mechanism was basically that when we talk about the achievement of elimination, or let's say elimination of these HFCs or any of these gas, you cannot have the same metric for a country like United States and the same metric for a country like India, Bangladesh, or Pakistan. That cannot happen in the same category. So that is why, based upon the economic parameters as well as the requirement of cooling, there was a phase target which was given, and the countries were divided into distinct groups. So as per the grouping, the first group consisted of rich and developed economies like United States, UK, and EU countries. And what was the target? The target was to phase down the HFCs by 2019 and reduce it to 15% of 2012 levels by 2036. That was the target. Okay, so by 2036, the amount of HFCs that these countries would be using would only be 15% of what they were using in 2012. Then the second group consists of emerging economies such as China, Brazil, and these countries. Now, here their phasing out has to begin by next year, that is 2024, and reduce it to 20% of 2021 levels by the year 2045. Okay, the third group would include or consist of developing economies and the tropical countries, which require high amount of cooling as well, such as India, Pakistan, Saudi Arabia, Iran. Now, there the phase out has to begin by 2028, and it has to reduce to around 15% of 2024-26 levels by the year 2047. Now, even though this target has been set, most of the countries are well ahead of the race. Most of the countries are set to overachieve their targets because majority of these countries, they have set into plan their own kind of cooling action plan where they are seeking to reduce the kind of emissions of these particular gases. But nonetheless, it provides a kind of a distinct target setting, and that is where it is much more achievable, much more implementable. See, just setting up of a target is not important. It is also much more important to understand whether you are able to achieve that target or not. For example, you are preparing for civil services. Let's suppose you are preparing for the year 2025. Now, if there's a pressure, let's say from your house, from your parents, does not mean that you set your target that, okay, now I will succeed in 2024 itself. And then even if I have not started the preparation, then I'll do one thing, I'll finish the general studies in 2 months, I'll finish the optional in 3 months, I'll finish the answer writing in 1 month, and I'll compete for the exam. That is not how it works. It will take its own particular time, isn't it? There's no alternative, there's no shortcut. So just by setting an aggressive target, what you're doing is you are diluting the concept of target itself. Because once you violate that target, let's suppose you set a daily target. Most of you, when you write a mail to us and when you write a mail to me, most of you have the same aspect and the same problem that you face. That I'm unable to fulfill my targets, I'm unable to maintain the discipline. And when I ask them that what is the target, so the target was that in this month I would finish 3 different subjects. Now that is simply unachievable. So once you start flouting the targets, then the target is simply a kind of a written text. It doesn't matter anymore. Just like Binika, as you are referring to, just like in the case of climate change conferences, the targets which had been set, many of the countries, they started to flout it, violate it, and as a result, it became a norm. And flouting a target was something which was acceptable to them. Okay, so as a result of these various processes, there has been a marked change in the health of the ozone layer. The ozone layer, which was in the 1970s, if you take a look at the Dobson unit or the concentration of ozone, that depletion quite intensified through the 70s, through the 80s and the 90s. Observe the amount of depletion which was observed in 2017. And it is that ozone layer in itself is on a path to recovery, whereas it is expected to reach the 1970s level again by the year 2060 itself, right? By the year 2065, and furthermore by the year 2100, but it is estimated that it will overachieve its target. So this is basically carried out, this assessment study is carried out by a UN-backed scientific assessment panel to the Montreal Protocol on ozone depleting substances, and this carries out a quadrennial assessment report. Quadrennial means carried out every 4 years. That is a quadrennial assessment report, right? So it confirms the phase out of nearly 99% of the ODS. Now here, why I have a smile is because when these reports are published, now in the case of this quadrennial assessment report, something very funny came out for the last couple of reports. Now we have all seen that methyl chloroform, CFCl3, etc. had been banned. Now this assessment report, which is furnished, is basically done based upon the scientific survey of the atmosphere with the help of the various satellites. And then it is understood and analyzed what are the sources of emissions, where is it that if still these ODS are to be found. Now, I'm sure I would have told this to you earlier as well, that when the last assessment report was carried out, it was found out that even though all the countries are saying that there is no production of CFCl3 which is happening anymore, but still in the atmosphere there are some traces of CFCl3 and substantial traces of CFCl3, which basically told the scientists that there is some country or some region which is violating the norm. Now, this report is carried out every 4 years. Now, every country was tasked upon this fact that where is it that it is being produced. Every country denied that we are not producing it. After 4 years, when the next report was finalized, then a much greater and a much finer look was taken upon. And then it was understood that you had a remote region in China which continued to produce these chemicals, not for their own domestic market, to be sold in the poorer countries of Asia and the poorer regions of Africa, so that they could earn significant amount of revenue. This immediately gained global traction and global attention. And China did what China does, what China is good at. So when actually the pressure was indicated and the pressure was mounted on China that how could you flout this norm, China basically did what it does. It denied. It said that no wrongdoing has happened, nothing doing, everything is fine. Upon greater study, it was found out that the particular factory, the particular region where this said production was carried out, that region's face in itself was completely changed. It was as if that region never existed, that production never happened. So thankfully, with the help of these assessment reports, we are able to pinpoint where is it that this kind of a flouting of norm is being carried out, if at all, in any particular area. Then, if the current policies remain in place, ozone is expected to recover to the 1980 values by around 2066 over the Antarctic, by 2045 over the Arctic, and by 2040 over the rest of the world. And this is where a prelims question can be extracted from. And the prelims statement can be framed in a way that the ozone layer depletion is experienced only over the regions of the poles, correct or incorrect? So the answer will be incorrect, because the ozone layer depletion is observed over the other areas as well. Okay, it is not to the same proportion as compared to the poles, but it is to be found in other regions as well. Then we'll take a look at few of the government initiatives which have been launched in order to combat air pollution. So these government initiatives, that is to combat and to fight air pollution, the scourge of air pollution. So here, when we take a look at it, first of all, the first thing that the government did was basically the establishment of CPCB. Now, CPCB is a statutory organization. Statutory organization means established as per the statute of the law, established as per the conditions of a legality, a legal matter. So that is where this CPCB was established under the Water Act of 1974. Important for prelims. Okay. This was established as per the provisions of the Water Act of 1974. It was entrusted with the powers and the functions under the Air Act of 1981 later on. And that is when CPCB became the nodal agency to take care of the air pollution as well. After this, CPCB became the nodal agency tasked with the aspects of air pollution as well. Okay, then It provides technical services to Ministry of Environment, Forest and Climate Change under the provisions of the Environment Act 1986 as well. And you had the various different state pollution control boards which were also established. They would carry out their own provisions and their own functionalities in the various states, and they would all then coordinate with the CPCB. Okay. Now, there was a concept of ambient air quality which was established. Now, that ambient air quality basically meant that the quality of outdoor air in our surrounding. Ambient means what? Ambient is derived from the term ambience. So that is basically the surrounding. When you are taking care of your surrounding, when you are looking at your surroundings, it is typically measured near ground level, away from very direct sources of pollution. Now, the Parliament also passed the Air Act of 1981. Now, this was enacted by the Parliament to implement the decisions which were taken at the Stockholm Conference of 1972. I'll give you the entire flowchart of all these conferences, of all these conventions next week when we are going to discuss about the international conventions and conferences. I'll give you the entire flow of it so that you have a better clue about it. So this was at the Stockholm Conference. That is when the three threats to biosphere were identified. One was climate change, another was loss of biodiversity, and the third was pollution. So that is when, after the Stockholm Conference, you had various different types of legislations and various different types of measures which were put into the motion to take care of these triple threats identified in the Stockholm Conference. Now, when we talk about the Air Act, first of all, do you need to learn this act in detail? The answer is no. Do you need to understand the basics of this act? The answer is yes. So the Act's framework is similar to that of the Water Act. It expanded the authority of the State Pollution Control Board and the Central Pollution Control Board. States which did not by the time of 1981, which had not managed to establish these pollution control boards, they were asked to establish this. An advisory committee was constituted, which would advise the center on the approvals. All industries operating within the designated pollution control areas need to obtain a consent or a permit from the state boards. Okay, all the industries, they needed a consent, and that consent would be based upon the kind of emission, the amount of emission that they would carry out. So the states are required to prescribe emission standards for industry and automobile after consulting the central board of, that is CPCB. Central board here talks about CPCB. So CPCB, what it will end up doing is it will consult with the states, and then the states will designate the set targets or also the set standards, and the industries are required to fulfill those standards. Okay, and then if they are not carrying out the emissions as per that standards, it could have led to the closure of the industrial setup as well. Because eventually, by the help of the Environment Act and so on, the power of the CPCB was expanded quite significantly. Okay, where the CPCB got the power to carry out search and seizures as well, and random inspections could also be carried out by CPCB. Okay, now this act was amended further in 1987. The boards may close down a defaulting industrial plant or may stop its supply of electricity or water when, if they are found to be flouting the norms, if they are violating the norms, then the boards can order a shutdown. Okay, now the 1987 amendment also included a citizen suit. That means it basically also included the provision that a citizen can file a kind of a PIL or can file a complaint, where the citizen, if it feels aggrieved, if it feels that these norms are not followed by any particular industry in general, it can file a complaint for that. Another very important fact for your prelims here is that the 1987 amendment to the Air Act extended the provisions of the Air Act to include noise pollution and the problems of the noise pollution as well. So noise pollution was also included. This is important. That is why a larger star. Important for prelims. Okay. Now, then in 1984, so in 1981 you had the Air Act. Then in 1984, National Ambient Air Quality Monitoring was started. For the first time, monitoring at the various different areas was started. Then, as we do, we renamed the various government schemes. So this was renamed as National Air Monitoring Program. 4 air pollutants were monitored at this point of time: SO2, NO2, SPM, and RSPM10. Then in 1985, the monitoring was actually extended to 28 different stations, and by 2012 it was extended to almost all the states. Then by 1994, National Ambient Air Quality Standard was introduced. A fixed standard was introduced, and it was basically monitored. Now this was revised in 2019, where 12 pollutants were introduced and they were basically monitored. Real-time monitoring was started. These were the 12 pollutants. Which are those 12 pollutants? SO2, NO2, PM10, PM2.5, ozone, that is the ground level ozone. After that, lead, carbon monoxide, ammonia, and so on. These were the various pollutants which were monitored on a real-time basis. The monitoring started on a real-time basis. Okay, that was a major change which was brought about. Then another major change was brought about in 2014. Now, what was the change brought about in 2014? Now, there, air quality index was introduced. Now, what was the purpose of it? Understand it once and for all. So, if let's say I tell you that this is XYZ is the concentration of SO2, Y is the concentration of NO2, Z is the concentration of PM2.5, A is the concentration of PM10, and so on, I give you the different numbers. As an individual, what would you decipher out of it? Because a common individual, we would not even be aware that what are the safe limits. A common individual can actually get disturbed by the fact that, okay, ozone is also present, SO2 is also present. So we don't get an idea whether that is good, whether that is bad, whether the amount of pollutant is less or whether the amount of pollutant is more. So that is why a combined index based upon the monitoring of 8 different pollutants, the 8 vital pollutants, after that a combined index, one number, one index, that is something which was arrived at. So here, this was a tool for effective communication of air quality status to people in terms which are easy to understand. And it would transform the complex data of various pollutants into simple nomenclature and color. So you had 8 different pollutants which were tracked. This 8 pollutants important for your prelims, not the previous ones. This is something that you need to keep a track of for your prelims. Okay, not the previous one. 12 pollutants which were established as per NAAQS, that is not required to be learned anymore. This is something that you need to keep a track of. So you had PM10, 2.5, NO2, O3, CO, SO2, NH3, and lead. So these were the various contaminants and pollutants which were to be kept a track of. So here a kind of a coloration was done. One color, one number, one description. So based upon the AQI parameters, it was decided or it was understood what is the level of pollution. If the AQI number is 400 to 500, that means the pollution level is very severe. If it is between 300 to 400, that means the condition is very poor. Okay, and just to give you a point of reference across the country, these are your various different AQI numbers. Generally, you will observe that the southern part of the country is much more cleaner in terms of the air quality index as compared to the northern part of the country. And there are multiple reasons for them, all of them geographical reasons. First is lesser population density, so obviously lesser amount of emission in per capita. Second is that in the southern part of the country you have a greater amount of green cover, so you have a better quality of air automatically. Third is the southern part of the country will experience the frequent exchange of winds in the form of land and sea breeze, and also being close surrounded by sea from the three sides, there is a frequent wind movement, so cleaner air as well. So all these basically contribute to cleaner air. In the region of Delhi, as you can see, the AQI numbers are around 391. But then this can be oftentimes deceptive because, for example, immediately after the festival of Deepavali, the US Embassy also has got a kind of a measurement tool and various different observatory stations in Delhi. Can you guess the number that they indicate, the AQI number? Many of these observing stations, they indicate. So now it has cleaned up quite significantly as compared to what was there in 2016, 17, 18. Now there has been a cleaning up. So basically, in many of these stations, they indicate a number of 999, the AQI of 999. So does not mean that the index is 999. That means your equipment is calibrated only to give you the reading for 3 digits. And that is where the US Embassy gave the correct reading because it had the equipment which could give the reading for 4 digits as well. And that is when the AQI numbers which were finally brought from the US Embassy, it indicated a number close to around 1200. So you can imagine the amount of pollutant load which is carried out due to stubble burning, due to the vehicular emission, and also due to the bursting of firecrackers. Can I note all these? Yes, you can always note all these, my dear friend. This is something which will be always required and very, very important for your examination. Then after that, we also have developed a kind of a forecasting and a modeling methodology by which we are able to forecast what is going to be the amount of pollution which will be created, which will be caused in the near term future. By feeding the data about the amount of pollution, the temperature expected, the wind pattern expected, all the various inputs that you feed in, that is suffer will give you a kind of a model or a kind of a prediction that in the month of October, this is the amount of pollution that you can expect. Now, what is the benefit of it? The benefit of a forecasting method is very simple. It helps you prepare for the future. It helps you devise policies and take administrative control measures aided for the future as well. Okay, so SUFFER stands for System of Air Quality and Weather Forecasting and Research. That is the air quality checking and the forecasting model developed by Indian Institute of Tropical Meteorology. Right now, here various different pollutants are measured. You don't need to be learning all of this, but keep a track of it, keep an idea about it, so that a random question, if it is asked in the prelim, should not stump you out altogether. Okay. Now, after this, we come to the portion of water, land, and noise pollution. So here again, the same pattern that we studied in the case of the air pollution, here also we'll follow the same kind of pattern. Any doubts that which prevail till now? Any doubts which are persistent till now? Feel free to ask. No doubts? Perfect. So now we initiate the discussion about the water pollution. Water pollution is quite pervasive and quite significant all across. And when we say water pollution basically includes not only the pollution of the surface water, it also includes the pollution of the groundwater. Now, when we talk about the groundwater, other than the ice caps, which is trapped in the polar regions, other than the ice caps, the groundwater is one of the largest reserves of fresh water that we have, which is available for drinking water supply, for domestic purposes, for agricultural purposes, etc. Successfully, we as a group of species, we have managed to pollute the groundwater as well. While we have managed to pollute anything which is present on the surface, be it land, air, water, everything, but we have gone ahead, we have polluted the space, we have polluted the underground as well. That is the reach of the human. So if anybody asks you that what is the reach of or what is the capability of the human race, this is also one of the capabilities that only the human race can have. So here, understand this, and UPSC had asked a question about this in 2021 about which has got the larger share of fresh water. So after ice, the ice caps, that is, here the ice represents the fresh water trapped under ice cap in polar regions and snow and glaciers. Okay, even in high altitude mountains, for example, Himalayas, they are very famously referred to as the third pole. So that is where you have these presence of the ice caps. Now, when we talk about water pollution, so broadly, in the case of the water pollution, there is a classification of pollutant which is done based upon whether the pollution is being carried out from one point or whether it is distributed. So that is the classification as point and non-point source. So when we say a point source of pollution, for example, you have the industrial waste. Let's suppose the industrial waste, the oil refinery waste, or any kind of industrial waste that you consume, that you observe, that is a point source where from one point pollution is happening. But when we talk about the non-point source, it is in a way democratization of pollution, where pollution can be carried out from any and every portions. For example, let's suppose closer to a river, you have a lot of human habitations, hutments, etc. Now, in the floodplains of the rivers, obviously these hutments, they won't have, many of them, they lack proper sanitation facilities. So all of them will have their sewage being discharged into the river water. So that is a non-point source. For example, early morning across the floodplains of the rivers, you will find a lot of human contribution happening in the form of sewage, excreta. That is a non-point source. So that is your basic classification between a point source and what we regard as a non-point source. Okay. Now, so freshwater pollution can be surface water pollution or a groundwater pollution as well. So, for example, you have the point and non-point sources. Example: sewage pipes, industrial waste, habitation, settlements. These can be the cases of point and non-point sources. The other aspect of freshwater pollution is the groundwater pollution. That is the pollution which is happening in the underground region. Now, when we talk about the ground pollution, underground pollution, what can be the reasons or the causes for the same? So here, this particular chart gives you an idea about what kind of pollutants are to be found in the region of the groundwater. So here, what can be the causes for the same? Causes for pollution. So first, Here, in many of the cases, you have, for example, let's suppose over the land area, you have large waste which is dumped. And that waste is not segregated. So you have large amount of waste which is dumped, including chemical waste, heavy contaminants, toxicants, metals, all of them. Under huge amount of pressure, there's some amount of liquefaction, and the toxins, they percolate and they seep to the lower reaches. So if this is the waste dump, under huge amount of pressure, toxicants or toxins percolate to lower layers. Okay, so that can be created by seepage or simple leaching of toxins from the surface. Other than that, we can also experience an over extraction of groundwater. So whenever you carry out an over extraction of groundwater, for industrial purposes or for any other purposes, whenever you carry out an over extraction, what happens? So groundwater, where is it present? So for example, when we talk about groundwater, largely we have an imagination that there is a very large layer consisting only of water underneath the surface. But groundwater is largely contained in the perforations of the various different rocky layers, in the various different pores and perforations of the rocky layers. Okay. Now, it is that perforations and that rocky layer or the rocky region which is saturated with water that is supplied. Now, if you continue to extract it and over extract it, the groundwater will bring about the contaminants of the rocks as well. The minerals of the rocks as well will be included in that groundwater. And that is where you get the contamination with heavy materials such as, let's say, cadmium, arsenic, even uranium. Certain areas of Punjab, the groundwater has indicated a kind of a contamination with materials such as uranium as well. So, over exploitation of groundwater. Then in many of the areas, it is the surface water of the river, which in a way channelizes some amount of that portion to get perforated in the underground region as well. For example, especially in the river valleys and the river plains. So there also, you have these contaminants present in the surface water, which finds its way into the underground region as well. So contaminants in the surface water causing pollution in the groundwater. Okay, so these are few of the ways how you can have the groundwater getting contaminated, even when you carry out mining. Now, even mining activities in many of the regions, they expose the groundwater with heavy contaminants. Why? Because when you carry out mining activities, you use a lot of water and they wash off those contaminants of the rocks, and those rocks, basically those heavy contaminants, they start seeping down and there's a seepage into the underground region. So activities such as mining. Then agriculture. Again, the same process of seepage. Now, in agricultural activities also, significant amount of various different types of fertilizers, chemicals, they are introduced, furans, etc., dioxins. Now, many of the times, along with the water and the surface runoff, they percolate into the lower regions. So these are the various factors which cause the pollution of groundwater. Okay. Then we come to the causes of water pollution. That is something that we will take a look at tomorrow. So for today, that is where we'll restrict the session. Any doubts that you have, feel free to ask. Otherwise, we'll wrap up the session. I hope the session has been somewhat understood. Borewell also, see, just digging off the borewell will not lead to contamination. If you carry out a significant amount of extraction, overt extraction from the borewell, that is when even that water will be contaminated. Or if you contaminate the borewell, then there will be contamination. Okay, right. So that is where we'll restrict the session here for today. Where there is uranium, can we have the deposits there? No, that is not the case. That is not how it works. Actually, uranium is found in trace amounts when you have the graphitic rocks, right? The graphitic and the granitic rocks when they are present. So it is in those rocks when you extract significantly. So that is where trace quantities of uranium is to be found. It is not enough to form a kind of uranium deposit. Okay. Right. So thank you guys for the patience of today. Tomorrow when we meet, what is it that we are going to cover tomorrow? We are going to cover the various conventions such as Stockholm, Rotterdam, Basel Convention. We are going to talk about the various different aspects of bioremediation, waste management, and also important legislation such as the Plastic Rules Amendment Act, Plastic Waste Amendment Act, E-Waste Amendment Act, the concept of EPR, Extended Producer Responsibility, the concept of climate change, greenhouse gases, the impact of climate change, the retreating of the glaciers, etc. That is something that we are going to look into, and then we are going to move into the portion of biodiversity, understanding the biodiversity hotspots, etc. That is something that we are going to take a look into tomorrow. So that will be all from my side here today. To take care of yourself, recharge yourself for tomorrow. See you again. Goodbye. Good night. Thank you. There are more conventions, much more conventions. This is not even scratching the surface, my dear friend. I'll tell you how to learn that.